Hi, we are Group 70 and my name is Chen. In this video, we'll be presenting on the Westgate Bridge collapse in 1970. On 15 October 1970, a construction disaster happened. A 2,000-ton bridge section collapsed, killing 35 men below. This is the Westgate Bridge collapse in Melbourne, Australia. The bridge was to connect Melbourne's western suburbs to the city centre to reduce traffic congestion. The project faced various difficulties like limited funding and contract issues, but it went on anyways. On the day of the collapse, a buckle appeared due to structural stresses, and when workers were trying to remove it, the bridge suddenly snapped and collapsed. Looking at the timeline, the construction started in 1968. During construction, two massive steel sections were built on the ground and lifted onto the support pillars. When they were placed together, one half was higher than the other, and to realign them, the engineers tried using heavy blocks to push it down, which actually worked, but the weight also created a buckle. On 13th of October, the head engineer Jack Hinshaw decided that the buckle had to be removed to avoid getting questioned by his superior. 2 days later, while workers are loosening the bolts, the steel snapped and collapsed into the worker huts right below. 35 men were killed and others heavily injured. After the collapse, investigation was conducted by the Royal Commission. Their findings concluded to two main causes. One, the engineering design by Freeman, Fox and Partners was flawed. And two, the project contractor, World Services in Construction, has used an unusual method of constructing the steel section. It was also noted that using heavy blocks for forced alignment was extremely risky, and the subsequent unbolting without following safety procedures were the main causes of the collapse.
Hello everyone, my name is Noor, and I will be talking about the engineering issues that caused the 1970 Westgate Bridge collapse. The first one was due to design deficiencies, followed by unsafe construction methods, the immediate trigger, and last but not least, systemic and organizational failures. For the first factor, design deficiencies, the collapse was mainly due to structural design flaws by Freeman, Fox and Partners, where the top flange was too thin and it lacked stiffness, which made it prone to buckling under load. And these stiffness were either undersized or poorly connected, which created critical weak points. And if this was in Malaysia, under the Legislation of Engineers Act 1967, Malaysian engineers must have recognized qualifications that could prove their competence and uphold strong responsibility for public safety when delivering professional services. For the next factor, which is unsafe construction methodology, Policy in 2020 highlights that the contractor's construction method, it involves lifting and joining unstable half spans of 50 meters above ground. And if this was in Malaysia, it reaches the Legislation of Engineers Act 1967 as well as BEM's Code of Conduct. The construction team, instead of doing engineering corrections, it forced alignment by adding heavy concrete blocks, which worsens the structural instability. The immediate trigger that caused the collapse was the attempt to fix the camber misalignment by adding 51 tons of concrete to force the alignment. And this excessive load, it caused the already weak top flange to buckle, which shows imminent failure. And the remaining bolts sheared under stress, which caused both half spans to collapse. And last but not least, systematic and organizational failures. There was a disconnect between the design and the construction, and this shows a lack of adequate supervision, where some engineers already raised concerns about buckling, but their warnings were ignored. And previous warnings from the Milford Haven collapse, it led to design changes, but only a few, and the design changes were insufficient and poorly implemented.
My name is ALIFF EZAQIEL. We'll now go into the ethical failures behind the Westgate Bridge collapse. The tragedy highlights critical breaches in engineering ethics. Firstly, the lack of due care and diligence was evident. FFNP rushed the design, leading to unchecked errors and compromising safety. There was also inadequate checking and oversight. FFNP's review of proposals was insufficient, and unclear roles led to confusion. Crucially, they failed to act on warnings. Even after a panel buckled and engineers warned of instability, precautions were neglected. Finally, misrepresentation and poor judgment. FFNP withheld critical calculations, downplayed flaws and dismissed safety reinforcement. Their personnel showed poor judgments due to outdated expertise. Taking this context to Malaysia, the Board of Engineers of Malaysia, empowered by the Engineers Act of 1967, outlines a code of conduct that seeks to prevent such disasters. At its core is the duty to public safety and health. Engineers must prioritize public safety above all else, a principle violated at Westgate. It demands competence and due diligence. Engineers must only work within their area of expertise and verify all data that they work with, which FFNP failed to do. The code also addresses responsibility for an engineering work. FFNP approved unsafe designs and mishandled transitions, violating the BEM standards. Lastly is integrity and honesty, which is key as engineers are barred from misrepresenting their work. FFNP violated this by obscuring design flaws. These BEM codes is vital for upholding ethical standards and safeguarding the public trust.
My name is IZZATI and I will present the recommendation and conclusion. For recommendation, first, involve independent third-party engineer to double-check all major design before construction. This helps to catch any design error early, especially for complex structure. Second, apply proper regulation of temporary work such as scaffolding or concrete blocks, which should be treated just like permanent structure. They must be approved by qualified engineer before use. Next, ensure clear communication and responsibility. All project member, designer, contractor and engineer must communicate clearly. One technical leader should be appointed to make a final decision. And lastly, need to promote ethics, safety culture and accountability. Engineer must prioritize ethics and safety over deadline. Regular ethics training is needed and teams should feel safe to report any problems. In conclusion, the incident happened due to design error, poor decision and weak communication, which cost 35 lives. This could have been prevented with better planning, proper check and strong ethical conduct. We have learned that design review, clear rules and safe construction method are essential. Ethics and safety must always come first. This tragedy led to important changes in engineering code and continue to be a powerful case study in engineering ethics and structural safety. And that's all from us. Thank you.